Good day everyone. What we have today is application of sequence and series. Sequence and series can also be applied to real life situation. So let's look at it. There are numerous problems that we can use the concept of arithmetic and geometric progression to solve or tackle. Example of it is a man receives an annual increase of 30 naira, and after a period of 10 years service, the man has a salary of 1,014 naira. Find his initial salary. From the question, what we're given is the amount the man collected on the period of 10 years, that is the 10th term. But the question now is, he said we should find his initial salary, the first salary he collected, which is known as the first term. So with this, let's see how it is solved. Like I always said, bring out the informations that are given in the question before you start looking for the ones the questions ask you to get. So already there we have our n is 10 on the 10th year. So the A initial salary, which is also T subscript 1, is what we're looking for. And then common difference, that is annual increase, is 30 naira. So from this, since you have an increase every year and that increase is constant, which is 30 naira, already we know that this question is arithmetic progression question. And so look at it, we are looking for the value for the 10th year, which is T subscript 10. So we just use the n term formula. But in this case, our n equals to 10. So just substitute 10 into the n term formula. Salary on the 10th year is given as 1,014 naira. So with that, we have salary equals plus 10 minus 1, which is 9. Then our 9 times 30, that will give us 270. So we have the 10th term to be A plus 270 equals to 1,014. So with that, we can move our 270 to the right hand side. And so when we deduct that, it means the initial salary that the man got was 744 naira. Considering the second question, this year the number of students in a new school is 600. For the next 10 years, the school will be taking 5 more students every year. How many students would have been taken in this school in 10 years? What is saying? The question is not like the first one. The first one is that after 10 years, how much did the man collect? That is the man's salary in the first example. That is to say, just calculate the value for the 10th term. But this question is saying how many students from the beginning, when they started registering students, so till 10 years. So that question falls under series, that is add the students they got the first year, which is 600, plus the students they got in second year until 10. That's series. So if it's series, that is sum of all the terms. And in this question, we don't have the last term. The last term is not known. It means it's a continuous sequence or infinite sequence. So if it's an infinite sequence where the last term is not known, we're meant to use the formula for sum of the n terms for infinite series, and that is our x subscript n equals to n over 2. Open a bigger bracket, you have your 2 times your a, plus smaller bracket, open n minus 1, close the small bracket, multiply it by your common difference, which is d, then you close the bigger bracket. Remember that your n equals to 10. First term is a, which is 600, and the common difference is 5. Just substitute all these values and you will get what you are looking for. That is the sum of the sums for 10 years. So that will be S subscript 10 equals to 10 over 2. Open a bigger bracket. That will be 2 times our A is 600 plus 10 minus 1, which is 9. So our 9 times 5. You close the bigger bracket, and so you simplify that, it will give you 2 into 10 will be 5. Then in your bigger bracket you have 2 times 600, that will give us 1200. Then plus our 9 times 5, that will give us 45. You close the bigger bracket. Then when you add what is in the bigger bracket, is going to give you 1245. Remember, you have multiplied by 5. So when you multiply this by 5, you are going to have 6,200, and that is your answer. That is the total number of students from the first year to the 10th year. So let's go to example 3. So you have a container full of oranges were shared among 12 market women in such a way that the first woman received 50 oranges, the second woman received 70 oranges, the third woman received 90 oranges, and so on. The question is, how many oranges were received by the I? You have 8 women. The number 2, the last woman. Then look at it. B question, how many oranges altogether were in the container? So look at it. We have solution in the A part of that question. So we're going to use, because we're going to use our n-term formula. So when you use your n-term formula, because we're using for the 8th term, so the formula for calculating any term in a sequence we know is our T subscript n equals to A plus open a bracket n minus 1, close the bracket, times your D. Then look at it. What we have in the question is our first term, which is 50, the second term, which is 70, the third term, which is 90. So if we want to get the 8th term, now. That 8th term, T subscript 8 equals to 50 plus 8 minus 1, close the bracket, 20 times 20. So if you have that, that will be 50 plus 8 minus 1 is 7. Then 7 times 20, that's 140. 140 plus 50, that's 190. So it means our 8th term, the 8th term is what? Is 190. So the woman in the 8th position in that sequence got 190 oranges. You can see it. The 8th woman, the number of oranges that woman got is 190. Then we'll move. If you check it, the last woman is the 12th woman. Okay, so let's look at it from the question. A container full of oranges were shared among 12. So that means it is the 12th woman is the last woman in that sequence. So we want to know how many oranges was given to the last woman. And so it means that your n equals to 12. So that means using the n-term formula, we just substitute our A, we substitute our n. And then we know that n equals to 12. So you have it to be T subscript 12 equals to 50 plus 12 minus 1 in a bracket times 20. Then you have 20 plus 12 minus 1 is 11. 11 times 20 will give you 220. When you add it to 50, you are going to have 270. So it means the woman that is sitting at the last position, which is 12, that woman got 270 oranges. Then last question is this: how many oranges do we now have all together in the container? Then that means we're going to calculate the number of oranges given to the first woman, to the second woman, to the third woman. So if you can do that, fine. but you can use the formula because we know the last term. Last term is the T12. We're going to use the formula for series when the last term is known. Already we know the last term and we know the value for the last term. So now you use your formula, that is your Sn equals to n over 2, open a bracket, a plus l, the value of the last term, then close the bracket. So you have your 12. Your n is 12, you have a 12 divided by 2, open a bracket, that's 50 plus 270, close the bracket. And so your 12 divided by 2 is 6. And then we have 6 into 50 plus 270, you close it. When you add 270 plus 50, that will give you 320. Multiply your 320 by 6. Then you are going to get 1,920 oranges. This is the total number of oranges in the container that was shared among the 12 women. Okay, so we pick another question, and this question is find the sum of all positive odd numbers that are less than 200. So odd numbers are 1, 3, 5, 7. No one, we're considering less than 200. It means 200 is not involved. The next odd number to 200 is 199. So we'll stop there. And so look at it. Our A equals to 1. When you look at how do you get your common difference? Your common difference is T2 minus T1, or T3 minus T2, or T4 minus T3. So when you look at that, they have a difference, and that difference is 2. And not only that it has a difference, the difference are constant. So if it's constant among the terms in the sequence, we are now talking about what we call the common difference. So with this, we want to get the sum. We want to get what's the total number of the odd numbers that are in between these numbers we're saying. So we have to use your n term to look for that. So if you look at it, you have what will be your n. You first look for your n. So you use your n term formula, that is your n equal, because the last term is given, so it's easy for you. The value for the last term is known, so you can find your n very easy. So you know your t subscript n equals to a plus, open a small bracket, n minus 1, close the bracket, and times d. So your a is 1. You now have 1 plus, open bracket, n, because you don't know your n minus 1, what's the common difference? 2. So n minus 1 in a bracket times 2. We know the value of your last term, which is 199. So you now have 1 plus, open the bracket with the 2 there, you have 1 plus 2n minus 2 equals to 199. And so with that, you have your 2n. You will see it there, 1 plus 2n minus 2. Already, when you collect like terms, minus 2 plus 1 will still give you minus 1. So you have 2n minus 1 equals to 199. And now you collect like terms again, push your minus 1 to your right hand side, move it to the right hand side. So you have your 2n equals to 199 plus 1. And so 199 plus 1 gives you 200. So divide both sides by 2. Your n will give you 100. Already we have the last term, and the last term is 199. And so we use the formula. The value for the last term is given. We're going to use the formula for sum of the sequence when the last term is known. And so look at it. You have your S subscript n equals to n over 2. Open a bracket, a plus l. You close the bracket. So you will say your n you already know is 100. So that will be 100 divided by 2. Then open a bracket. Your a is 1. And while the value for the last term is 199, you close the bracket. So when you add that, 1 plus 190, that will give you 200. Then 200 times 50, that will give us 10,000. And so let's quickly move. What we did till this point is application of arithmetic progression. Now we want to go to application of geometric progression. In problems relating to appreciation of the value of something as in a compound interest, as well as depreciation of an item over a period of time. When we have questions on appreciation of values, like for example in compound interest, or we have depreciation over a time, so we can also use the concept of geometric progression. Okay, let's consider examples. You have example 1. A man deposited 2,000 in a bank at 15% compound interest per annum. Find his total amount at the end of the 3rd year. In general, at the end of the n year, the total amount accrued is going to be initial payment times the common ratio. See, the common ratio here is at the first payment is 100%. Each year 15%. The rates up on that money will be 15, just 15% across. So for the whole 3rd year is going to be 15. So it means that the common ratio is going to be what? 100% plus 15. Because that money is appreciating. So it's 100% plus 15%. So at the end of that, we're going to have our common ratio to be 1.15 or 115%. And so at the end of the 3rd year, the total amount you're going to have will be the initial times the common ratio raised to the n, that is the number of time you have deposited that money, and which is 3 years. So it's going to be your initial deposit 2,000 naira times 1.15 raised to power 3, because it's for 3 years. So the total amount for you for that year, for that 3 years, is going to be 6,750 naira. So then we have depreciation here. So that depreciation, look at it. Mr. Kola bought a machine which depreciated each year by 5% of its value at the beginning of the year. The value of the machine when new was 1,000 naira. Find its value when it was 4 years old. That is, each year it depreciates by 5%. And so that means a 5% reduction. It will be the value of the at the end of the 4th year will be A times the common ratio raised to power n. Our n is what? 4. So you're going to have 1,000 naira times 0.95 raised to power 4. So with that, the value at the end of 4 years of that machine that was 1,000 will now become 814 naira 51 kobo. And we have come to the end of application of sequence and series. How a sequence and series can be applied to your everyday life. So this is assignment that will aid your understanding in this application. So after solving this, you can also get from other textbooks where you can solve more questions. Remember, in mathematics, the more you solve questions, the more you understand it, and then the more you can apply. So that's why we started from concept, and now we move into the real life application. You are welcome to the next class. Thank you.